My name is Keenan Chatar, and I was an international intern at NASA Ames Research Center in 2018. I studied electrical and computer engineering for my BSc in engineering, and I studied also integrated systems. And now I'm here at Kyushu Institute of Technology in Japan, studying for my additional master's in space engineering, where I also work on satellite development. And I'm currently working on development of the Birds 5 nanosatellites, which is part of the Birds 5 project here at QTech. Yourself?
And my name is George Maeda. I'm assistant professor at the same school as Keenan. We're located on the southern island of Japan called Kyushu. And I've been here since 2015. I report to Professor Mengu Cho, who is the director of our laboratory. Since 2009, I've been editor of the International Space Weather Initiative newsletter, and since 2016, I've also been the editor of the Birds Project newsletter. Thank you.
Okay, thank you for your introduction. I think we can move into one of the questions. So the first question is, what are some applications of satellites, and how can developing countries use them? You can go ahead and answer first.
Okay, so to my audience, I want to emphasize that this is much more realistic than you realize. I think many of you still think of old space instead of new space. Maybe some of you know the difference, but it's a big difference, old space and new space. Old space was the Apollo era, when rockets were big, satellites were big. Satellites cost $100 million to $300 million to develop, and they often took 10 years to develop. And as a result, they were super reliable, but super expensive. So that's old space, and I think a lot of you are still in the mindset of old space. In the past 10 years, there's been a paradigm shift, and now it's called new space. The cost has dramatically fallen. So on the screen now, you can see a 1U CubeSat. Okay, so the cost of this is say $150,000. It weighs about 1 kilogram, and it doesn't cost much to put this into space. And so these are affordable to developing countries. And I will defer to Keenan to mention some of the applications. Go ahead.
Sure. So from my perspective, some of the applications of satellites, they're limitless. So they have applications in communications, land surveying, weather forecasting, and conducting in-space experiments. So an example of these applications is the primary mission of Birds 5, which is a multispectral image capture for member countries Zimbabwe and Uganda. So they're using it for land surveying and agricultural purposes. So these satellites, they're being built by engineers from these member countries. So it goes to show that satellite development and these applications, it's not just a dream goal for these developing countries. It's accessible, as you said, these small scale satellites with very, very cheap costs, or relatively cheap costs compared to larger satellites. It's available to developing countries and interested individuals. So I think that's a good answer for the applications of the system.
To mention two applications that Birds projects often use. One is store and forward. This is because if you have a cell phone network that covers the entire country, then you always can communicate data from any place in the country. But many countries, you have dark spots, which have no access to any communications whatsoever. Right. In that case, the only method would be via satellite. And so store and forward allows a small transmitter on the ground to uplink when the satellite flies over, and then when the satellite is over some urban area, it can download the data there. So that's storm forward. And the other application is remote sensing. You know that you can buy all kinds of pictures and data from commercial operators, but there's many drawbacks to that. So if you can do remote sensing with your own satellites, you have many benefits. So I'll stop there.
That's good. Those are excellent applications. I think maybe you can move on to the next question now. So to the young audience that are interested in satellite development, what do you think, what would you say are the skills, educations, or traits required for building satellites? Can you run?
Okay, so I believe there are 3 items that you need. First one is intense curiosity. If you don't have that, then you won't go very far. Then the second item you need is passion about space. When we talk about satellites, we're talking about space. So you need to be passionate about space. And the third item is engineering background. So if you're in high school wondering what to study in college, if you want to build satellites in the future, well, then you should pick an engineering subject. It can be any engineering, civil, chemical, mechanical, electrical, computer science. It has to be a 4-year or a 5-year, very solid engineering program, concluding with a bachelor's degree in engineering. So if this is too formidable for you, well, then the space engineering is not for you. I turn it over to Keenan now.
Sure. I'd like to build on that last point that you made, that I realized that satellite development is primarily in the engineering aspect. So one of the main areas that you can probably focus on. So like if you're a high school student or still wondering which engineering to choose, you can probably choose one of the primary ones. So such as electrical engineering, computer engineering, mechanical engineering, or one of these subfields. And maybe after you completed your BSc or such, you can specialize further in space engineering. So in my case, I specialize basically in computer engineering. I like computers, building them. And now moving forward, like I'm slowly learning into space engineering. I realized that the space field, they comprise of many of these different fields. So while I'm specialized in computer systems, I still have to know a bit about mechanical systems, a bit about structure, and so on. So it's kind of a jack of all trades, but it's quite interesting if you have a thirst for knowledge and learning different things, learning about space engineering. While it may be a niche field, you will still have to keep in mind all the different fields, but it's still very interesting.
Can I add
the
to
one
that?
that you can learn? Sure, go ahead.
So it's possible that you're passionate about space, but you're not crazy about engineering. Don't worry. There's still a lot of things you can do. Space is a booming industry. It's a sunrise industry. You probably know that many industries today are sunset industries, but space is just taking off now, and there's a demand for many kinds of professionals. We're talking like space law or space financing or management, business. It's a very long list. So if you're not crazy about engineering, but you're still passionate about space, there's plenty of work to be done. Thank you.
Nice. And maybe we can move to the final question. What advice would you give to persons interested in satellite development but don't exactly know where to start?
Okay. So I think we covered that already. You need a strong engineering background. However, you should do some things outside the academic sphere. Joining organizations like what's that? SGAC?
IEEE, SGAC, like astronomy clubs and so on. Is that what you mean?
Exactly. So, Keenan, maybe you can say something short about SGAC.
It's GAC. I'm not part of that club, but I'm part of IEEE and my basic astronomy club for my country, Trinidad and Tobago. And it was, you're right, being part of clubs and meeting different people who have the same interests as you, it helps spur curiosity and so on in your
and
in
it
your
also
field.
it also develops your human network,
Correct.
which is
Which
important.
yes, that's also one thing I learned that's important
So
as well.
when you go to college, you acquire knowledge, okay? But you don't make that much of a human network. So
Right.
what I'm trying to say is, once you become a professional, a working professional, sometimes whom you know is more important than what you know. So you need to work on both of that, both knowledge acquisition and people acquisition.
I think that's important, yes.
I'll turn it over to you, Keenan.
Sure. I think the advice that I would probably give is that I wish someone told me earlier that building satellites for your country or in general, it's not really as out of reach as you think it is. As you mentioned before, people think old space and new space. Like when you think space or old space, it's you think of NASA, SpaceX, and building giant rockets. But we can actually, like new space, you can actually build for developing countries small-scale satellites that can achieve many, many goals. And it's within the reach of aspiring young engineers and scientists. So just keeping that in mind, it's not as outlandish as you think it is to enter the space industry and begin learning and creating new things.
So let me add to one more piece of advice.
Sure.
If you get a BS degree in engineering in your country and you speak English fluently, one thing to do is come to Kyushu Institute of Technology to get a master's or PhD degree in space engineering. That's one way to get started.
I'd say so too. That's what I'm doing.